course. Some of the eruptive phenomena are flares, CMEs, coronal mass ejections, and just various streams of charged particles that are being accelerated or decelerated by events on the surface or in the corona of the sun. These emissions interact with our magnetosphere, ionosphere, and thermosphere. And as far as aviation can go, they really can have a big impact on communication and navigation systems in aircraft, or on Earth, or in your car GPS. They can present a biological hazard, certainly for pregnant women, especially in high altitude flights over polar regions, or even for air crews that are subjected to continuous flights at high altitudes. It's no laughing matter. It can definitely cause biological harm. It can obviously affect the operation of electronic equipment such as power grids. We've all heard of the late 90s and early 2000s when there were blackouts attributed to solar phenomena in the northeast US and southeast Canada. The sun is a massive, massive, mighty force for us as Earthlings. It controls everything on this planet, in my opinion. Well, it's not an opinion, it's fact. The solar wind has an effect on everything. And when it gets extreme, or when it gets very low, it can have startling effects on our planet and our technology. You got to remember, we developed all this fancy satellite-based technology really in the last 40, 50 years during a period of relatively calm solar activity. So there's really no telling what's going to happen if we do have a really high maximum. Hopefully it won't be enough to eliminate our species, but we're definitely likely to lose internet or satellites, cell phones, etc. for brief periods of time over either this solar maximum or one of the coming solar maximums. When I tell students that, they're really shocked to learn that, hey, I might not be able to use my cell phone. It's possible I can't finish my game of World of Warcraft on the internet with a guy in Thailand if there's a big solar flare. So I try to explain to them, the best way to handle that is to lift up from the chair, open your eyes, walk to the front door, go outside and look around. That's how you handle loss of your internet. It's no big deal. Of course, we all grew up without internet, so we understand this. But when I tell them, your text messages may be disabled for a couple weeks due to a solar flare in the next 3 years, you should see the faces, oh my God, oh my God. And I try to explain to them the manual method of sending a text message, which is to walk to the person you'd like to speak to, open your mouth, verbally send the words using whatever language you both can understand. Let the other side hear it and understand it, and then reply to you by opening their mouth and doing the same thing. So that's the manual text message method, patented by Stephen Ramsden. Space weather impacts on aviation. This is October of 2003. It's called the Halloween CME, or magnetic storms, that occurred on the surface of the sun. And I'd like to thank NOAA Space Weather Prediction Center for providing me with some information on this. That was the wife, Natalie. Hey, Natalie. As you can see, the SOHO cameras and sensors were pretty much overwhelmed by this storm. It was so massive. The coronal mass ejection that occurred from this is massive, and we're probably going to see this or greater during this solar maximum. Look at that CME. Boy, that is fantastic. Of course, the middle image, very low, is an X-ray image from SOHO. The coronagraph is inlaid over that in the red, and then I forget what they call the larger blue camera, but that's the same one that recorded Comet Lovejoy here recently. It's a big deal. Excuse me. Coronal mass ejection, what is it? Coronal mass ejection is what it says it is. It's a mass of the corona being ejected from the sun. And as you can see on the far right, at the edge of the sun, the photosphere, seen here I believe in X-ray, or the chromosphere, will contain a solar flare or some type of energetic phenomena that will be released into the transition zone into the corona. And the corona is a very, very low density, high energy environment, so it doesn't take a lot to push off a chunk of it. The corona is much, much larger than the sun, extends out millions of miles as the outer atmosphere. And when this flare event occurs and goes into the corona, or sometimes when a comet passes by, as they like to show on SOHO and get everybody going, it'll trigger an ejection of material from the corona outwards into the solar system. And as you can see in the center picture, the inner heliosphere, it's quite an energetic occurrence. The solar wind density graph on the bottom left shows you how high the solar wind peaks. And on the far left, of course, is Earth, and the CME is buffeting Earth right here. You see how it passes Venus, goes to Earth, and it causes a big deal. We've been around for several billion years in this type of solar wind, so we've evolved and developed safeguards naturally against this. Hopefully we won't be overwhelmed by it sometime soon. But it is a very, very hostile environment. It's not a beautiful orbiting planet like they show on the History Channel sometimes. It's a hostile, empty environment. Hazards to aviation. In 1994, the FAA categorized flight crews as radiation workers. That's pretty significant and a good recognition by the FAA on the dangers of crew radiation exposure. Pregnant women, especially who fly regularly, might exceed the recommended radiation exposure. The FAA wants its air crews to understand the health implications of their occupational exposure. And in 2009, a report of the National Council on Radiation Protection and Measurements, or the NCRP acronym, concluded that occupational radiation doses received by pilots and flight attendants are the highest for any worker group in the United States. And in those days, let's see, 2009, which is relatively recently, we're still flying at basically 35 to 41,000 feet for air carriers. That's undoubtedly going to increase. The troposphere generally is bounded at 50,000 feet. And as aviation progresses through its various cycles, it's constantly elevated itself to higher and higher altitudes to save fuel and decrease time in the air. And once you get above 50,000 feet, you're in a whole new realm of the stratosphere, which has much greater radiation hazards to flight crews. A lot of us in the FAA really don't have any idea about this because it's never really been an issue. I don't believe anyone's ever been killed by a solar flare in an airplane. Hopefully no one ever will. But the point of this whole safety briefing is to get you to understand an introduction to the solar wind and how it affects aviation. This is an actual occurrence, and this probably can cause damage to flight crews, especially, and even passengers on single flights if their solar events are extreme enough. There's a guy, forget his name. Well, there's a book called The Invisible Passenger, Radiation Risk for People Who Fly. And it's somewhat alarmist, but it's got a lot of facts in it that are very interesting. And I've read through the book, and it's something that, like I say, we don't really concentrate much on now because nothing's ever happened. We like to wait until someone gets killed before we react. But the thing here is to be exposed to it and understand what's going on, so you, as a safety professional or an aviation professional, can react appropriately without panicking. Personal dosimeters are recommended by European flight crews. In fact, European law requires all carriers provide radiation training and dose assessment for their aircrew. This is a very, very complicated topic, and there's a lot of alarmist reactions, and there's a lot of underestimating of the facts involved in this. And it's my goal in my program, since I have the position of being in aviation as well as solar astronomy, to try to make sure that knowledge is given and people understand the situation. Because that's the key to reacting properly, is full understanding of what's going on. Now, primary sources of exposure are cosmic radiation when you're not in a solar maximum. That's radiation from outer space. It's constantly there as well. It's not quite as severe as a massive solar flare, and we've lived with it for so long that we've kind of evolved to withstand a lot of that thanks to our magnetosphere. But it's generally thought that crew who spend substantial flight hours over 30,000 feet need to address this problem, especially female crew who may become pregnant or may be pregnant at the time they're flying. What can you do? Wear a dosimeter if you'd like. I'm sure your air carrier company will provide you one. Believe me, they don't want any liability. Share information about your level of exposure with a healthcare professional. Educate yourself about the patterns and routes that you fly and how they can affect your levels of radiation you receive. That's really key to it. And learn about ionizing radiation and how it relates to you.